Welcome to my channel. This is an educational channel that will share educational videos on various topics of power electronics. Topic is SCR commutation. It is one method used to bring an SCR or thyristor from on state to off state. We know that an SCR can be activated by using a gate signal toward an SCR when it is in a forward bias. But SCR needs to turn off when required for power controlling, otherwise power conditioning. So for this, we will see the different methods of commutation. These are the commutation methods, that is a natural commutation and a forced commutation. In natural commutation, the source of commutation voltage is the supply source itself. If the SCR is connected to an AC supply, at every end of positive half cycle, the anode current goes through the natural current 0 and also immediately a reverse voltage is applied across the SCR. In the forced commutation, in DC, the SCR do not turn off naturally, so extra circuit is required to forcefully turn off it. Hence, it is called forced commutation. Voltage commutation and current commutation. Voltage commutation, if reverse voltage is applied across the SCR. Current commutation, if thyristor current is forced to reduce below holding current. For commutation, Class A commutation, Class B commutation, Class C commutation, Class D commutation and Class E commutation. So Class A commutation is also called the load commutation. Class B, it is a resonant pulse commutation. Class C, it's a complementary commutation. Class D is an impulse commutation and Class E is an external pulse commutation. Class A commutation. This is also known as self-commutation by resonanting the load or simply the resonant commutation. In this commutation, the source of commutation voltage is the load. The commutating components are inductor and capacitor, and the capacitor can be connected either in parallel or in series with the load resistance RL. In this circuit, we can see that load in parallel with capacitor and load in series with capacitor. First, we have to understand when load is connected in series with the capacitor or across the parallel with the capacitor. So, we can say that when values of resistance, inductor and capacitor are low, then in that case the elements are arranged serially along with SCR as it is shown in a figure or in the circuit. On the contrary, when the load resistor possesses a high value, that it is connected in parallel across the capacitor, while this parallel combination is connected in series with the inductor. So, both the cases it is shown in the figure itself in the circuit. So, you will see the working of a Class A commutation. So, on applying the external DC input, or rather you can say that by applying an external DC input signal, the current starts flowing through the circuit. In order to turn on the SCR in the circuit, a gate trigger pulse, that is this one, it is a gate trigger pulse, is required. So simultaneously gate signal is applied. So here the gate signal it is applied that will put the thyristor in forward conduction. Okay. So here it will put the thyristor in forward condition there, or you can say forward conduction mode. So we have already discussed the same, that gate pulse is necessarily required to turn on the SCR. Hence, after the SCR gets on, the forward current that flows through the SCR begins to charge the capacitor. Where the capacitor is there, it start charging. So hence after the SCR gets on, the forward current that flows through the SCR begins to charge the capacitor. At the same time, the inductor connected in the circuit stores energy. So we know that the property of an inductor and what it is, it opposes the change in current. So once the capacitor gets charged up to the peak of the supply input, the polarity of the inductor connected in the circuit will get reversed, and now the inductor will oppose any further flow of a current through it. As the inductor does not further allow the flow of current, the output current starts to decrease and reaches to and just to 0 there. Okay. So this means here the commutating components make the current through the load 0 and this commutate the thyristor. This signifies that unlike the turning of the SCR where the gate terminals acts as a direct switch to turn the device on, in the turn off no direct switch exists, and so with the use of external component the device is commutated. In the waveform, if you see here, we can see it's clearly represent that by providing gate pulse the SCR gets on. So what you have to do, first you have to provide the gate pulse. Okay, after providing the gate pulse, what will happen? In the capacitor will charge and the voltage across the capacitor reaches the peak of supply input and simultaneously current flows through the circuit. In the on state of SCR, the drop across the SCR will be 0. So here after the capacitor gets charged up to the supply voltage, the inductor releases its stored energy and opposes the further flow of current. So the energy released by the inductor further energizes the capacitor, and this is shown in the waveform. See, the value of load resistance and the commutating components are selected in such a way that they form an underdamped RLC resonance circuit. So when the circuit is applied with the DC source, the forward current starts flowing through the SCR, and during this period the capacitor is charged up to the value of VDC that we have seen in the waveform also. So the current in the circuit will be either of the two waveforms depending on how the load is connected to the capacitor. Already we discussed that when the circuit is to be in a parallel and in a series. A load in series with the capacitor, that we see the waveform here. Load in parallel with the capacitor, that also it is given here. Conducting the current in the SCR is the charging current of the capacitor. So from the waveform, it is clear that the current becomes 0 at the point K. So at this point, the SCR turns off. The resonant frequency of the circuit, which depends on the commutation components L and C and also on the load resistance, determines the time for switching of the SCR. So class A commutation method is simple and reliable and is usually used in high frequency operations. That is frequencies in the range of 1000 Hz and above due to the high values of L and C components as they carry the full load currents, that's why. So this type of commutation is generally used in series inverters. So this is all about class A commutation. So in the next lecture, we will see the different commutation again. So till then, bye. Thank you so much.